Hello children, welcome to channel Sube. Today I am going to discuss question number 43 from MCQ part of 2019 Physics New Syllabus paper. 3 right angle prisms of refractive indices n1, n2 and n3 in brackets n2 is greater than n1 and n3 both are arranged very close to each other on a table as shown in the figure. There are no gaps between the contact surfaces of the prisms. A ray entering through the face AB with an incident angle I refracts at faces AB, BC and CD and DE and emerges from the face DE without deviation. The angles of refraction at the faces AB, BC and CD are R1, R2 and R3 respectively. Which of the following expressions is incorrect? So sin I equals n1 sin R. So there are 5 answers given. We have to choose the incorrect expression. So let us try this question to solve. So they say in this question that and emerge from the face DE without deviation. So what is the meaning of deviation? So from this surface emerge from the face DE without deviation. So first of all let us revise a little bit what is deviation. Angle of deviation. The angle between the incident ray and the emergent ray is called the angle of deviation. So that means this one is the incident ray. So the direction of that incident ray is this way. The direction of incident ray is this way. So what is the emergent ray? So emergent ray is this one. This one is the emergent ray, that is the ray leaving the system. So that is called emergent ray. So what is the angle of deviation? The angle of deviation is the angle between the incident ray and the emergent ray. So suppose the emergent ray leaves the prism like this with an angle to the incident ray, the direction of the incident ray. So this angle is called the angle of deviation. So it has a value like this. So they say in this question without deviation. Without deviation means the deviation angle is 0. The angle of deviation is 0. So little by little this angle decreases and approaches the value 0. So now the angle of deviation is 0. So this ray can be located at anywhere, up or down, doesn't matter, but the angle is 0 according to the question. In this story the angle is 0, the angle of deviation is 0. So that means it is parallel to this ray is parallel to the incident ray. So like this. So they have drawn in this question exactly it is parallel to the incident ray. So we don't have to edit it. So that means this ray is like this, parallel to the incident ray, parallel. So we can draw it like this. If we extended this emergent ray like this until it meets incident ray like this, so we can see now there are 2 parallel rays to each other. So now we can find out some details about this angle I. This one is the normal to this plane AB. So I extend it like this So let us see if there is a relationship between these angles, because we have to solve this. We have to start solving this problem from somewhere. So this one is, they say, angle I. So since this blue color rays are parallel to each other, and they are crossed by this normal means to this green color line is perpendicular to the plane AB. So since this angle is I, so what is the angle this one? What is this angle? How much? That also I, because this one and this one, because these are correspondent angles. We know this one is I. So this angle is opposite to this one. Therefore, now we can mark that this angle as I, same to this one. So again I say this angle is I, it is given. So this angle also, you can see, must be same, because these lines are parallel. So front of this angle, this one also I. Then now we know this angle is I. So you have to mark it like this. Then see this line. Again I copy this line and move it to, it is exactly, we can locate on this, we can place on this BC surface, because perpendicular. So this line we can move to this place and can place on this DE plane, DE line, exactly one over another. So that means now these two green lines are now parallel to each other. This one and this one are parallel to each other. So those parallel lines are now crossed by this one. So now focus your mind to this angle. What is it? Since this one is I, can you see the same size of this angle? Same size, because these two parallel lines are crossed by these two parallel green lines. So this angle must be equal to then I, the same I, because this angle also is correspondent to the angle that we discussed earlier. So the emergent ray is now invisible because I placed this blue line over it, so I have to draw it again. This one is the emergent line that we want. This one is the emergent line. So now we know this angle is I. That means the equal to the incident angle. But what we want is to use in equations the angle between the normal to this DE plane and the emergent ray. So this one is the normal. This one is going to be the normal to this DE plane at this point. So what we want is this angle. This angle is the one that is in the equation formula. So what is this angle? Since this angle is I and this total angle is 90 degrees, so you can easily understand that this angle must be equal to 90 minus I. 90 minus I. Because this angle is the emergent angle. This one is the emergent angle. So now we know emergent angle is 90 minus I. So we are going to use this term in Snell's equation after a while. Therefore you have to keep this in your mind. So now let's assume the value of n2 is 1.6. The value of n1 is 1.5. The value of n3 is 1.5, because they have mentioned in the question that n2 must be greater than other two. So n2 is this one, it is so now greater than other two. Then what is the n refractive index of this air outside? It is 1. Refractive index of air is 1. So both sides you can write 1. Then we have to consider this incident ray is entering to a medium whose refractive index is higher than the medium of this incident ray. So it is entering to this higher refractive index medium, so it must turn to towards the normal. So like this it might strike here on this surface. So now we have to draw the normal to this plane, to BC plane. So 90 degrees, so we place it here. So now the ray is entering again to a medium whose index is higher than early one. So then it must turn again towards the normal. So it was heading this way, so a little bit let's turn like this, not much, because here the difference between these two refractive indices is difference is much greater, therefore the turn is greater. But here the difference between these two refractive indices is smaller. You can see 1.5 to 1.6. Therefore the turn is the deviation is smaller. Therefore we can't turn it as much as earlier. So I turned it a little bit according to these values of n1 and n2. So now again I have to draw this normal perpendicular to DC surface. Now see the refractive indices, the number 1.6 to 1.5, n2 to n3. So again not much difference, you can see. So therefore the turn is smaller, and now going to a lower value, therefore it must turn away. It must turn away from the normal. It was heading this way, a little bit turn away like this, heading this way. It was heading this way because it came like this, and it was heading this way. We have to turn it away from this normal, so the angle increases, and you must connect with this point again. It must continue like this. So now we have finished drawing this, tracking the path. So the refracted ray must be following this path. So now we can mark the given R values. So this one is given as R1, this one is given as R2, and this one is given as R3. So now what we have to find is, already we know this one. So if we look at these answers, most of the answers contain this N3 and R3. N3 and R3 here. All these three answers have N3 and R3. Therefore, if we used this 3 value from here, if we started to solve the problem here, I think we can easily finish this calculation. If we go inside this, it will be hard. Therefore, let us find out this angle and try to use the formula. So what is this angle? Already we have found this one, but now we have to find this one. So this one R3, R3. So using this R3, we can find this one easily. How? If we extend this line like this, and also this line like this, we get a triangle, right angle triangle here. So since this angle is R3, what is this? What should be this one? This one is 90 minus R3. 90 minus R3. So now let's apply Snell's law. What is it? N1 sin I equals N2 sin R. The refractive index of a medium and the angle in the same medium, and the refractive index of the other medium and the angle in the same medium. So here the refractive index is N3, so we write N3 sin the angle of that side. So this one goes with this one, and this angle goes with this index. So sin, so we have written N3, this one, so angle of the same side, so this one 90 minus R3, then equals N2 is this side now, so it is 1. So therefore we don't have to write it, 1 times sin R is sin this value, in the same side index and the angle. So 90 minus I sin brackets 90 minus I. So now we have to solve this, because there are no 90s here in these answers. So do you know sin 90 minus theta equals cos theta. That is the equation you have to keep in your mind, and also you can write cos 90 minus theta equals sin theta. So here we can substitute it, N3 sin, instead of 90 minus R3 we write just R, cos not sin now, cos R3 equals, here instead of sin we write cos, just I, theta is I here, cos I. So they have taken sin I, cos I to left side, therefore let us change the places. Cos I equals N3 cos R3. So this one is the answer we received. So let us copy it and check. So this fifth one goes with this one, so this one is correct. So if this one is correct, this one can't be correct, because N3 cos R3 is equal to cos I, but here they say, so we received this, we derived this. This one is the correct one. So here they say n3 cos r3 equals to sin I. That is wrong, because we know surely n3 cos r3 is equal to cos I, not sin. Therefore we can mark this one is wrong, this one is correct. But what we have to select is which of the following expressions is incorrect. So this one is the answer then. We don't have to check these others, because they must be correct. All these must be correct, because only one answer is wrong here, incorrect. So we have chosen it, we have selected it, we have found it. So children, the answer is the third one. So I think you can understand. I very slowly calculated this. So thank you very much for watching my videos. Watch them again and again. So see you tomorrow. Goodbye.